Hey, how's it going, y'all? Today I'm gonna go over group anagrams. This is a problem that I've solved before, but I feel like just with the thinking that comes along with this, it helps to sort of get a grasp on um, breaking a problem down into smaller subproblems, but also leveraging the manipulation of the variables that you're given to work better in your favor. And so for this problem, we're given an array of strings, and we're supposed to group the anagrams together. So an anagram is a word that has a sequence of letters, and each occurrence of the each unique letter has the same number of occurrences for another word. And this saying you can return the answer in any order. So for this example, we have eat, tea, tan, ate, not, bad. So then the anagrams here, we have bat, not, tan, ate, eat, and tea. And so I guess what we need to think about is just how to initially think of this problem, right? So the goal is to group words that have the same number of letters, a same number of unique letters. And for this case, we have E and T. So I would check for an E and then an A and then a T. And then this one, I would check for an E and then an A and then a T. And then since those work together, we would put those in the same group. And I feel like by this point, you should understand that you would want like categorization for each of the problems or each of the words that you find as you traverse through it, and making sure you are, if you don't have the same occurrence, then you would want to create like a new bucket, for example. So when I go through this string, or when I go through this array, I'm going to check for what letters I have within it, and then I'll create like a new bucket, quote unquote, say for that, and then I'll have like another bucket for this one. But the letters do match up a bucket that we had before, so then we'll want to put this one inside of that. And I feel like that kind of just displays what you would need to do as you iterate through the string. Um, and a good data structure for doing this would be a hash map, because the hash map you can indicate what the key is. So that's a big thing here. We need to figure out what the key is going to be and how we're going to determine if another word falls under that category. So given that, I would just um, like sort of what's like a common thing we see between these two words, right? They have the same letters, so how can you determine a key that would be the same? And you're probably thinking like, oh, we could probably sort the string, right? And that is definitely a good way to go about it. Although the time complexity does run a little bit higher because of that, but you're still, at least you're sorting each of these words into their own buckets. So then that's kind of what I did. It's, I think, yeah. So I sort the string, split. Yeah. So this is, so I convert it to like a array. I sort it and then I join it to convert it back to a string. It's kind of um, taxing on the operations, but that's just how it is right now. Um, and then so I have if dictionary has its own property of sorted. So this is to see if we have the key existing. And if it does, we're going to push that string into it. And so our dictionary is going to slowly come out looking like, I don't know what eat when it's sorted would be. Oh, I guess it would be AET. AET would be the key, and eat would be thrown into that that bucket, quote unquote. And then going forward, if we find like the same key, then we'll just oh, sorry, yeah. When we find the same key, we'll push it, and then otherwise we'll just set the new create a new bucket, for example, or just create our new key and then put in this for the value. And then we'll iterate through the keys within our dictionary and then return the values that are within it. So this way we'll have like a new array of the arrays of the buckets, or however you want to um, decipher all that. And then thus you would get this kind of, I'm not sorry, you would get the output that we're expecting. So I guess like the main thing to really keep track of here is um, think of it in a way where you can make it easier for yourself. Like, so when you're given a problem, they oftentimes will structure it in a way that's harder to decipher or like to read. But if you just take it verbatim and just go like, oh, okay, I mean, I feel like it'd be super convenient if I could have some sort of key and then just throw words into it that fall under that key. So then now I have to figure out what key it is. So what could be a good key? Well, we don't want to um, just take the first word. That doesn't make any sense. Or like be comparing each letter using like a separate data structure to count them. It's like, um, how can I make this word equal this word, right? And once you determine that factor, that's where it makes a lot more sense. And be, yeah, I mean, that's kind of how I would go about it. I mean, if you think there's a better way to do it, let me know. But this is kind of the solution that makes the most sense for me, and it's really easy to articulate to whoever you're explaining to, whether it's like an interviewer or another colleague, whoever that may be. And yeah, I mean, thanks for watching. That's the explanation. Leave a like or comment or subscribe, whatever your heart desires, and I will see you for the next video. Bye bye.